Hello there, and welcome to another video of CS202. Today, we're going to be talking about inheritance and protected variables too, but primarily inheritance. So, inheritance is a very interesting topic in C++. Before I tell you what it is and what it solves, let me tell you the motivation to learn it. Let me tell you the problems that are solved by inheritance. Okay? So, you're coding, you learned how to do classes now, you're an expert in classes, and you start building all these encapsulated object-oriented classes, and you're really happy with it. You're like, this is amazing, I'm doing all this great work. You're making car classes, you're making airplane classes, it's like Forrest Gump, when the whole thing was different shrimp, but you're doing it with classes. So, you're really into classes right now. Like, you're loving it, right? But a lot of the times, you make a class, it'll be this nice little box that you see here. It's got a bunch of stuff in it. But then all of a sudden, when you finish the class, you're using the class, you're using it for a lot of stuff. But then all of a sudden, you're like, well, you know what? I really like this class. And your boss is like, yeah, this class are amazing. You're doing like this great upgrade in productivity. But then come those dangerous words. Wouldn't it be great if? And what follows those words is going to increase your work tenfold, right? Wouldn't it be great if we could add this, or we could change this, or we could remove this? We could do a bunch of things, right? So typically what that ends up being is you want to have the same stuff you had before, but all of a sudden you want to add extra features to your class. Whatever those features might be. You might want to add, for example, your car class. You got your car class that has all these things, but now you want to add the ability for your car to also keep track of air conditioning. You want to add an AC unit to it for the rear passenger. So just an AC unit in general. That means extra variables, extra functions, but you still want to have the same functionality of your original car class because you're loving it. Okay? So what do? Well, one of the things that you can do is you can go ahead and you can literally copy and paste your current class. So you take your class, copy and paste it, change the name. So, if this is called say car1 or just car type, then you can get creative and call this car type v2, and then add whatever you want. So add that extra features, and so on. Extra functions, extra variables, etc. You can do that. You can copy and paste, call it a day. In fact, if we visit our example for the car, and I wanted to make another class. In fact, actually, before I do that, let's back it up. Back up the code. There we go. Backed up. Let's make another one to have it ready to go. So now that I backed it up, you're like, okay, I want to make another class of this. So what am I going to do? I'm really going to take this. I'm going to go down here. I'm going to copy and paste it. And I'm going to call this car type version 2 per se. And then, you got to do a couple of other changes. You got to change your constructor. Okay. The destructor name as well. And the declarations of the objects. All the times that you're referring, you're defining functions out of the class. Every time you see, in fact, you could do a find and replace thing. Pretty to do it quicker that way. But I think that's it. Let's see. Yeah, okay. So we got it. We got a car V2 now. And now that we have a new thing, we can add that extra thing. So we're gonna add in what's he? I know I said AC, but what would be something simple? Let's say we want to keep track of the color of the car. Just something simple like that. It's the public variable color. Okay? And maybe you want to do a couple modifications, like have a constructor set it. So, maybe set the color to be by default. Well, I think white is the most popular color of cars nowadays, right? I think white's number one, and then black is number two, gray number three, close three, like two and yeah, something like that. But either way, so we're gonna default as the most popular. And of course, we could add some functions, extra functions and stuff. And yeah, we could do that. We just add the functions like accessor setters, and you can make a private event, all that stuff. And it works. I mean, this is a viable solution per se, but it's not the best solution that you can do. And here's why. 2 years down the line, Tesla or whatever, your cars are in the production line and you sold a lot of cars and self-driving works amazing and everything. But then there's a bug. You find a bug. Turns out that your accelerate code, let's say they have actually shipped with this code. And like let's say that somewhere in the let's see, where's the accelerate function? Actually, here, better than the bug. Let's say that because I don't want to say my code was buggy, but like let's say the government implies a rule. Nowadays, cars and this is not far fetched because they just passed a rule that said that you have to have like like there has to be the car has to be able to shut off by 2026 if the driver's impaired. Like the car has to be able to detect if a driver's impaired and automatically shut off. So like they don't know how they're going to implement that. But like I guess it could be like an alcoholimeter or some kind of thing, or based on facial appearance. Like if they look drowsy, I don't know. Again, I don't want to get into politics, but that's something that they pass, right? So you got to go back and you got to add a function that checks that. Right? And if so, then switch the is on to, I guess, to off or something, okay? So when you do that, you run into two problems. One of them is you have two versions of this code. So, and they both different. And I know what we just did is a very simple thing. We just added color. But like the code can evolve to the point that it can be pretty complex between one version and the other. Furthermore, who knows how many other versions of this code there are if this is how you've been doing it by just copying and pasting it. And lastly, even if it's as simple as adding a function, you're going to have to go in and add a function to every single instance of this code. So like, if I got to go into card type, and I'm going to add in whatever the extra function is. So we're going to say like, void, foo, whatever, add that function, just whatever, it's nothing. Imagine that's the code. Now I got to add in this and copy and paste it into the other function, into the other class. Make sure it's like around the same spot too to make it easier to debug in the future, and so on, right? Similarly, if you find a bug, you would have to fix the bug in all instances of that you actually did this copy pasting. So it's not very good for maintenance. And when you get to 326, they're gonna talk about readability, reliability, and writability of some code. And among those tiers, readability is not that good when you copy and paste code because that just makes it harder to read when you just have repetitive code and you're like, what is the difference between this code and why is there so many of the same? Reliability, because like if you find a bug, you might fix it in one of the versions, but if you don't know that other versions exist, then you might not fix all of the bugs and that might come back to bite you, especially if it's like an exploit. You think you fixed a 0-day exploit, and then it turns out that other people were using it because they copy and pasted. They're vulnerable, right? So not good there. And it's not very writable either when you're just having to copy and paste code everywhere in the same place just to fix one bug. So not cool. Okay, but we still want to have that ability to be able to easily expand on an existing class. The other alternative is we could just modify the original one, but that's like messing with legacy stuff. Like you might break things because older versions of the code may not support the new things you want to add, and that can cause problems. So you sometimes can't modify the original one. You want to leave that be intact. So you want to have still a newer version with more stuff, but not break the original one. So you're at a standoff. What do? You copy paste or you modify the original one. Well, there is another solution, a better solution. That solution is the topic of the day, which is inheritance. Okay? So finally, 10 minutes into this, I gave you the reason as to why. So now let's see the real solution with inheritance. Okay? So what is inheritance and how is it really going to solve all our problems and make our days much better? Well, inheritance it's a little bit misleading with the name, because when we think about inheritance, we're thinking about generational stuff like parent-kid kind of thing. And, when you think about you inheriting a trait from a parent, typically what that means to you is that you are getting a copy of a trait from your parent, right? And inheritance isn't technically a copy. It's more of a reference. And that means that because let me put it to you this way. Let's say that your dad or your mom has blue eyes, okay? And or your parent, one of your parents has blue eyes. Doesn't matter who, okay, or what. Let's say that you have blue eyes because of that parent. Like genetically, you inherited that blue eye gene, okay? Let's say that at some point, I don't know, your dad or your parent, gets exposed to like, I don't know, some like the Joker thing. Like he falls, like your parent, your dad's the Joker, and he falls into the acid pit or whatever, and or chemical pit, and his eyes turn green from that. Okay, so you are the Joker's kid. You inherited the blue eyes from your dad, the Joker, but just because the Joker's eyes got changed to green because of something that happened in his life environmentally, it doesn't mean that yours are going to immediately change to that, right? I mean, you're predisposed, I suppose, if you fall in the chemical pit to turn your eyes green, but they're not linked together. Like you get a copy at the time of birth, and then that's it. Like you don't have a link anymore. Like whatever happens to him, you're predisposed to those things, but you don't necessarily mean it's going to happen to you, right? That's how genetics go. So that's inheritance in like real world. In computer science, it's a little bit different. In computer science, when I'm saying inheritance, what I'm saying is that you're linking certain traits and references to the parent, and they're permanently linked. So in this case, if your dad, the Joker, fell into chemical pit and his eyes turned greens, yours would turn green as well, even if you didn't fall into the pit. Because your eyes are a reference to the parent, meaning that like, if for some reason at some point you ever update the parent's eyes to be green, then yours will change because yours are saying, whatever the parent's eyes is what I'm going to go with at this time. And like, if it changes in the future, then at that time they're different, then at that time I'm going to get a different one. Okay? Why is that a good thing? Well, think back to our example with the bugs. If you find a bug in the parent code, the child code is going to have the problem too. If you fix the bug in the parent, because the child is a reference to the parent, then the child's going to also be fixed. And that's good. That's what we want. We want to be able to easily update any sort of derived kids. Okay? So it's like, I guess, if it worked like that with real humans, it's like, if we found a genetical disease in the parent and we somehow cured it, then all of the kids that the parent had would automatically get the cured, or like would be cured. That would be cool, actually. But yeah, so that is what it is. So before I go any further, let's talk a little bit about terminology. Okay? So when we're dealing with classes, which is what we're doing for inheritance, we have two kinds. We have basically the parent and the child. Okay? So those are the most popular names. For the classes. So we have the parent class, parent class, and the child class. The parent is going to be the original one, the OG one, and the child is going to be basically what came out of that. Okay? That sounds weird. Okay. There are other names though for this, and I want to make sure that I cover them. And I will interchangeably use a couple of them, but either way, just to try to get you to remember them all. But you should know them either way all. But stick to using one set of them usually when you're writing documentation. But again, be aware the other ones exist in case that you run into them. Okay? So a lot of if you've talked to like Java developers, they love using the term superclass and subclass to refer to parent and child. There's also the base class and the derived class. Okay, and they all represent parent and child. Okay, and then I think those are all of the ones that I can think of: parent, child, superclass, subclass, base, derived, Can't think of anything others. But if you can think of any, leave a comment below. What you would you know, and we'll all learn from that. So yeah, those are really the three main ones that I can think of. Parent, super, and base all mean the same thing. Child, sub, and derived mean the same thing. The original one and the kid. Okay. So let's look at a practical example of inheritance in C++. Okay. So let's go ahead and just create a class. We're just going to call this class A. You'll see throughout the semester I love using class A just because it's one letter and it's the first of the alphabet. For now, we're just going to stick to everything public. Although this will come into play. Remember public and private, and I said like there was this protected thing and they would come back to us, like this whole chart. Yeah, we're going to finish that today. In fact, look at that. Look at that word right there, derived. Now you know what that is, right? So, TS, I like to tell it because of that. You can reference like anything at any time. Okay, so this class, we're just going to put a random variable. I'm just going to put an int x. Gets initialized. We can even put a function as well. Void foo. Doesn't really need to do much. We're just going to make it cout x for now. Okay, so that's it. That's our class. And by the way, friendly reminder, don't forget to always put your semicolon after your class parentheses there, because I tend to forget. So yeah, okay. So you really love this class. You're like, this is the best class ever. It's amazing. Like, best class ever. Best class ever. But like, you know what? I really want to add another variable, like an int y. Because like maybe this int class x represents like a one-dimensional line graph. But now you want to do a two-dimensional line graph. Okay? And so that's what you want to do. And okay, very cool. So you could, of course, do the copy-pasting approach, which we said is not good. So we're going to do the inheritance approach. So how do we do the syntax for inheritance? What we're going to do is we're going to create a class B. And whereas before, if you were just making a normal class, this is the point where you would just use your open curly braces and your close curly braces and list everything in the class, right? Okay. But we want to inherit class A. We want to say, I want class B to have everything from class A, plus whatever I create now for class B, which is extra. It's very simple to do it. All you have to do is put some colons, and then put the class that you want to inherit from. So in this case, class A. So I am saying class B is brand new, and its parent is going to be class A. I'm saying like take everything from A and stuff it in B basically, and then start adding more things from there. Okay, so I did intentionally leave some space here. We'll come back to that in a minute. But let's go ahead and add some things to class B. So again, I'm trying to make it now like a two-dimensional graph. So I'm going to add an int y. I can do that. I can add in another function. So like maybe I'll add a random function, void bar, which does the same thing, kind of like cout y. I can also modify functions from the original class. So like, I could have a function here in the original one. So let's say I had a function that just printed out it's called function print. In the original one, all it did was basically print x, which to save time, I'm just going to call foo. That would work actually. But in this one, I wanted to print out both x and y. So in this one, I can basically overwrite. So this isn't overloading. You're not overloading the function. You're overwriting the function in this case. So if I say void print with the same parameters, then I'm overwriting it. And in this one, I can say, I'm going to go ahead and print out x and y. So I can either just cout them, or I can still call foo from the original one but also called bar. So it prints out both. Yeah? So you can add new variables, add new functions, or should I say add new member variables, add new member functions. You can also override, either one term I guess works. Override is the popular one. So in case you don't understand me, I'm saying override with, it's 1 hour or 2 hours now. I don't even remember now. Override, I think it's 1 hour. So you can override. Okay, that's the word I'm trying to say. Or you can override a function as well in the case of print. Okay, so and this whole overriding concept is going to be, we're going to revisit that when we see virtual functions, because when we start playing with pointers, we're gonna run into some problems with this overriding stuff. So it's not the last we'll see of it. Most of the things we're visiting now, we're gonna revisit, because it's hard, to teach you a bunch of things when everything's interconnected. So you have to kind of go piece by piece and then go back and add more and so on. But yeah, so those are the 3 main things you want to do. Okay? So when you do that, the cool thing is, if you ever update your foo function, or you ever update your x variables, or you ever add anything else to A, it will automatically be part of B. In fact, technically speaking, I did update A right now because I added that print function, right? Well, guess what? B already has that. But then again, I did override it, so that was that. Okay? Now, one more thing about this. Why did I leave a space here? This is legit code. It will compile and run, I suppose, in theory, as long as, well, I don't have any client code where I'm actually creating an object of this class. So, then I will run into some issues. But in general, it'll compile and be okay. But there is one more thing you should really add. And this is one of those things that, like, you should always stick to what I'm going to tell you until you know better. And then you should do whatever you think is right. And so, just like member variables and member functions can be defined as public or labeled as public or private, with your public thing here, so this, you can also inherit publicly or privately or protected once you learn that. And so by default, if you write it like this, just like by default classes are private, by default inheritance is private. And most of the time, you actually want to do a public inheritance. So you want to write the word public there. Okay? Again, some cases you do want to inherit with protected, and maybe even some cases you could possibly want to inherit with private. But I would say those are the exceptions to the rule. And unless you actually have a real reason to inherit that way, you should probably stick to doing public there. Okay? You can control the independent variables within the classes, which is the second thing. So when I do an inheritance and I say public here, what is that really doing? So I have a couple of variables. Well, I have one variable actually in class A. And that's variable int x. This variable is a public variable, meaning that it's accessible outside of the class and also inside of the class. In fact, all variables are available inside of their own class. When you inherit, it needs to know what property it's inheriting as. So is it going to remain a public variable? Is it going to remain a private variable? Or is it going to remain a protected variable? Which again, we haven't gotten to, but we will. So it turns out that this label here with the inheritance can make things more quote-unquote secure, but not less secure. What that means is that if you have a public variable in the parent class that you are inheriting from, and you inherit as public, it'll remain public. But if you were to inherit as private, so like if I were the word private there, here, or if I just didn't write anything and defaulted it to private, then all of the public variables here would automatically become private, which may or may not be something that you're trying to do, because typically if a variable is public in the parent class, it's because you want, or a function particularly, not variables as many, but functions. If a function is public in the parent class, you probably want that functionality to remain and still be accessible in the inherited class as public. If you don't do it, then it'll be private, and then only you will be able to access it within the function, within the class, and not outside of the class. So That's typically why you want to keep it public so that things remain public. But now you might be saying, oh wait, what if I had a private function? Like what if I had another variable here like this? Int g, okay? Because I put it on the top, by default it's private, right? Because if there's no label, then it's private. And the labels only go from there to the bottom. So but right now I have a new variable, g, which exists in both class A and also class B because class B is inheriting from A. So this variable g is private. And you might be thinking, oh, I'm inheriting with the public label there, so now the variable is public and I can access it outside the class. No. The labels here with the inheritance can only make things more secure, not less. So something that's already private or protected is going to stay private or protected and is not going to magically become public. So you can't do this as a workaround to access private variables. I'll show you some point how to get a workaround and get a little hackish when we learn about dynamic memory allocation and whatnot. But for now, until you know better again, just assume that they're not accessible. Or they're impossible, quote unquote. Okay? So, yeah. Private stuff will stay private even if you write public. Which is why, again, it's best to just leave it public. Because that basically guarantees that anything private will stay private, anything protected will stay protected, and anything public will stay public. If you set it to private, then everything will just default to private, okay? Now, you can actually inherit like multiple layers. So I could create a class C that inherits from class B. And those permissions carry over. So if you have a class C that inherits from class B, so like if I have class C inherit from class B, the permissions that I had here are going to carry over to here. So of course I need to put the word public or private or something here so that I am clear as to what I'm doing. But they're going to carry over. So if at some point you made things private here, like if this said private instead of public there, then by the time they get here, they're still going to be private. And so, yeah, you're going to have a problem accessing things. So when you inherit something privately, you really can't access it much. Like you run into problems. So again, avoid as much as possible private unless it's really what you want to do. Okay, so that's how public and private work when it comes to inheritance. As a rule of thumb, keep it public until you know any better. Okay, and remember, just want to refresh you, structs and classes are pretty much the same thing in C++. The only difference being the structs are private by default. Structs are public by default and classes are private by default. Okay, so if somebody asks you on a test or something, what is the difference between a class and a struct in C++? The answer is there's only one difference. Structs are public by default and classes are private by default, okay? So because of that, you can actually do inheritance with structs too. And in that case, that's a good question. In that, if you do inheritance and with a struct, will it default to private or public? I think it'll still default to private, but I'm not sure. Maybe it'll be public. We should try it out later and see what happens. And if not, you should try it out. So yeah, because we don't really use structs anymore. We just stick to classes. Because why use structs? It's a legacy name from C. Yeah, we should try it. Yeah, we'll try it out. If it was live lecture, I'd tell you to remind me, but now I have to make sure I remember myself. If not, try it out on your own and leave a comment below. Tell us what happened. So yeah, okay. What do I want to show you now? Actually, maybe now's the time to show you protected. But for that, I'm actually going to go on code this because I want to show you the errors. This can get a little tricky, so better than using the tablet. Let's go ahead and do this, okay? So let's start from scratch because this stuff is as cool as the car example is. I think we've kind of used it up, and it's too big now to show you. So it's better to just start clean. Okay, so let's come up with another example, something short and simple. So I'm just looking around to see what inspires me. for the example. Sometimes when I do live lectures, I ask people, hey, give me examples. And sometimes they give me some crazy stuff that we end up regretting it like two classes later when we're trying to implement stuff. So I'm going to go ahead and do... batteries. I think batteries. Yeah, batteries might be good. Okay? So, because I feel like that's something that we can upgrade. Kinda, maybe. Yeah, we'll do a normal battery and then do like a rechargeable battery. I don't know. Okay? Alright, so we're gonna make a battery type. Alright, so for a battery, we're gonna keep things simple. We're going to have the milliamp charge. Let me see how you spell that. Yeah, I think it's MHA, but let me just check. MAH. Yeah, capacity. Okay. I have a really old battery here. It's like a power bank actually, but yeah, okay. So capacity, we're gonna make a variable capacity, double capacity. By default, we're gonna make it 10,000 milliamps. I don't need to put the measurement. I'll put it here as a comment. Okay, and I guess the wattage. Nah, we'll screw that for now. Maybe I/O voltage. Nah, we'll keep it very simple. We're just gonna make it capacity. Okay. Maybe we'll add in a function. We'll call it print. We'll have a print function that's gonna be like a details of it, which is just gonna print out the capacity. Followed by the MAH milliamp. Okay, and I think I'll call it a day on that. All right, so let's just test our class, make sure it works. I'm sorry the tabbing is now, I like the double tabbing, but at some point it got switched. It's a pain. I hate that. It doesn't like that, yeah. Okay, so let's go ahead and make a battery. We're gonna call it B1, battery 1. And let's just go ahead and, is it public? Is everything public? No, let's make it public for now. Actually, let's make the variable private and the function public. Just so we have a variety of things, okay? Now I'm going to go ahead and do print. Okay, so here we go. We have a battery and it prints out the capacity of it. Very cool. With line feed there to make it nicer. And there we go. Okay, so such a great success, you know. Now, but as you have this great success, the federal government comes after you because you didn't say where it's made from. So now you want to add in, you want to inherit this, and actually, you know, we'll come back to that. We'll say that we'll add that in once we do that. So actually, you have great success. You want to make a version 2 of this battery. So you want to keep the legacy one because it's still selling pretty well. So we're gonna make a new battery. We're gonna call it Ultra Battery. You know, gotta get that name hype. It's going to inherit publicly from battery, and it's going to add, in this case, well, I guess we can increase the amperage, or so not the amperage, yeah, the output amperage or something, some output thing. Like some people really wanted this, so we add some output amperage. I don't know, kind of making this up as I go here. So we're gonna add, this now has a capacity. Actually, you know what? Here, in addition to being a battery, now it has like what could be cool? I apologize for not coming up with a creative example with batteries, but maybe it has like a second power bank. Okay, like a backup one, like an emergency backup. So like, you have a reserve. So like, because people procrastinate charging stuff and doing things, like there's a reserve for like if you're stuck in the wilderness, you can push a button and like the reserve turns on. Okay, so like reserve power. Yeah. That's more interesting. the reserve power is just going to be 500 milliamps. It's like an emergency, like, you know, kind of quick charge, like just a little bit of charge, just to call like the emergency number if you're like in the middle of the forest or something. Okay, so and then we you know, we want to make that private as well, and then we want to have like a thing to activate it. So maybe like a public function can be like activate emergency charge. So we'll just call it activate emergency, and we're for emergency charge. Okay, we want to keep variable names somewhat short, and so same with function names. So what this is going to do is it's going to take the capacity value you currently have, and it's going to take the current value of that, and it's going to add to that the 500 from the reserve, which you should use the reserve keyword in case it's not actually that. And then, yeah, that's it. Oh, actually, we want to make sure we remove it. Okay, so reserve gets 0. So it's like it transfers the reserve into the main power area or something. Okay, don't ask me how that's done or why you would do that like that, but just embrace it that that's what we're doing. Accept it. Okay, now already there we're running into an issue which I like. Okay, so if this was public here, we wouldn't run into any issue. So here, actually, let's keep it public for now. We run it, you know, and we want to see what the capacity is. Let's say that we need to add another function like use battery. So let's just add a function called use battery here. So use battery, and then it has like an amount that you use, like the draw per se. So it's going to be, I don't know, some parameter. We can do a double U for usage. And basically, you take capacity and you subtract from that the usage of that. Yeah? Yeah. So I was like the logic in my head. Okay. So yeah. Okay. So let's just see if that all works. So like, let's say we use the battery. So V1 use battery. 500, 5,000. This is 10,000, right? Yeah, 10,000. So let's say we use 10,000, and then we print out again the battery value. So you can see it goes out, right? Yep. And if we were to use this again, then we go to 0. Okay. So that works. So now let's go ahead and actually make a new battery, the ultra battery. So ultra battery type, we're going to call it B2. And so now B2, you can call print from our original B1 function, and it works the same way. In fact, let's just copy and paste the same thing that we did already, but instead use B2, right? So we're going to print out the battery data, we're going to use some battery power, and we're going to print that again. And you can see here, this is from the first battery and the second battery, and they have the same identical thing. However, the second battery has our activate emergency supply, right? So even though we haven't depleted the battery, you know, the time has come. Execute order 66, I guess. Activate the emergency battery. So we activate the emergency battery, and then we print it. So you can see now it is at 5,500. Yeah, 5,500. Because we use that instead of it being 1,500. Why am I saying 5,000, 5,500, right? So yeah, so it works. So our ultra battery does have that reserve, and we can charge twice the price or not twice the performance because we get away with that hype marketing, right? So you know, we get the influencers, we get some YouTube ads, we get some Twitch streams on people on like the middle of nowhere using the battery, and then we selling it. So yeah, okay. So cool. You know, it's we got our second battery, and then of course, like you already kind of saw how me implementing it here, this function already automatically kind of flows there. But just to show you further that, then comes the government and says like, yo, your battery doesn't say where it's made from. So like, I know you didn't do that because you didn't want to tell them it's made from China and you wanted to pretend it was made probably in the US or something. But yeah, you got to state that because, you know, you got sued or something. So you're like, darn, okay. Well, thanks that you're using inheritance, all you gotta do is just create that here. So I can go in here and say string made from, I guess, or maiden, or manufacturer location. I don't know, I don't know, whatever you just get maiden. We'll call it maiden. Sounds weird. It's made in China. Okay, and you just make it some public variable because you're like, I don't care if people delete it or something because you don't want to show them where you made it. I don't know. So now if I can print out the maiden function. Oh wait, it's a variable, so actually just see out it. It'll work on the first battery, but it'll also work in the second battery. You also need to set it to something, so let's just let's make it a constant string so people can't modify it, I guess. Okay, so we can print it out, and you can see both say made in China. Okay, so voila, you are able to update not just the base class but the derived class. You're able to keep your code nice and fresh and updated by only changing it in one spot. You can still enhance your derived class as much as you want, so you can have more features that are not present here. But anything that you do enhance on the superclass is going to be also enhanced in your subclass. See, I'm switching terms just to make sure you remember all of them. Okay, so that's the power of inheritance right here, and I think it's very powerful and very useful. However, let's go back to the issue that we actually kind of got to see here. Right now, everything is public, right? But like I spent the last class like an hour, almost hour and a half, preaching to you about abstraction and information hiding and how you don't want people to mess with things like capacity, right? You don't want the capacity. You don't want somebody to, YouTube video or TikTok video that's like, here's a hidden trick how to improve the capacity of battery. Go in there and change the capacity variable to, instead of being 10,000 to being 11,000. And then people do it and it works, and you can actually squeeze a little bit more performance until like a month from now, a battery explodes because maybe there was a little, we left a little tolerance if the battery overcharged a little bit, but like if they're constantly overcharging it, the thing is going to explode. And unfortunately, it exploded in the plane crashed, there was like fatalities, and now we're all going to jail, right? No, that's not going to happen, but still, I hope it doesn't happen. But yeah, so there you go, a big lawsuit because you did not make your variable private, okay? So you want to make it private, but then as you're using inheritance, as you saw, we run into a problem right here. Even though we're inheriting publicly, we run into a problem here that says battery type capacity is private within context. Let's see what that error looks like in the terminal, because I always like to see this in the terminal because sometimes it's better than VS Code, and I do want to make sure that regardless of the ID you're running, you see the same errors that I do, because you can always see those in the terminal with G++. In member function, void ultra battery type activate EC. Error, double battery type capacity is private within this context. So you are like, huh? Wait a second, why am I getting this private error as if I'm working inside of a class? Let's see what line it's coming from. It says it's coming from line 23. And it says that there was declared private on line 7. So line 23 isn't on a derived class where we're actually just trying to access the class variable. Now this class variable is part of ultra battery type, but it got there because of the inheritance. So it's coming from here. But I told you already that like private classes, you should be able to access them in the derived one, right? Like I should be able to get in there and modify it. So you're like kind of scratching your head like, okay, what do I do? How do I fix this? And on one side, you could make it public and then get sued after the plane crashes, or you could keep it private and have to copy and paste code around to still get to use all your cool code, in the derived class, right? Because you're already inheriting publicly, which means that it should keep all the protections. Well, here's the problem. When you have a private variable and you do inheritance, the variable does exist here. Like it will exist here. So like if I don't have this activate stuff, like if I just remove this let's just uncomment this, leave the function, but just uncomment it for now. Everything still runs. Like I still have access to the variable. But the only way that I have access to the variable is through the public functions that are in the parent class. I can't technically access the variable from my own parent. So like going back to the eye color example, your dad, the Joker, has the blue eyes and you have the blue eyes. You can't change your eyes, if this is private, you can't change your eyes to green magically. He can, and when he does, you get affected because he's the original owner of the code, per se, the parent. You can't change it because it's private. And if it's public, anybody can change it. So you're sort of stuck in this like standoff of what do you do? So for that comes our third term that I talked about but didn't really finish because I didn't, wasn't the time yet. But now is the time. That's protected. That's going to be your middle ground. Protected is going to be the best of both worlds when it comes to inheritance. Let's go ahead and fill this chart out for the other two spots that we hadn't gotten to yet. That is going to be, let me pick a new color. Derived for public and private. So we know for public, it's like YOLO. You can access it anywhere you want. You got it. For private, we saw doesn't work for derived classes. You can't access it. You have to do it through a messenger function, essentially. It's the same as if you're outside of the class, basically. And so the middle ground is going to be that we want to keep the same security as private does. So we want to keep this. This is good. This is a good thing for us. This is how we prevent people from breaking our code and then suing us because it doesn't work, even though they broke it. That's what we want. But we also want this part here that public provides. So we want this, and we want this. But obviously we don't want this or this, right? And so the middle ground is going to be, of course, for protected to be there. Because protected does not let people outside of the class access your code, but does let derived classes access the code. So it's that middle ground that we want and are looking for. So protected to the rescue. And so that's how we solve our dilemma. If we bring this back, and we bring the error back, as you can see by that, what I'm going to do is I'm going to go ahead and instead of writing private there, I'm going to do protected. And my problems will go away. So now I still cannot access. So if I try to access from B1 the capacity directly, if I try to say cout B1 capacity, and I run it, let me run it directly in this terminal here, I'm going to get an error saying capacity is protected within this context. So similar to the private error, it's just I'm getting the word protected instead of private in the error message, which is good. That's exactly what I want. Similarly for B2, I guess I gotta move the code down after the declaration for that one. I'm gonna get similar error. Battery capacity is protected. So as you can see, it's still not accessible from anywhere outside the class, but now we are able to access it and modify it in our activate emergency charge function to decrease it. So there is our savior, protected. Okay? So now you know what protected is and when to use it. Again, from a design point of view, my recommendation to you is if you are intending to use inheritance, when you first assign a class, if you don't intend to use inheritance, you stick to the keywords public and protected, public and private. If you're already, when you're writing your code, you're sort of writing a common class that's going to be shared amongst multiple classes, then that's where I would recommend that you already implement things that you would otherwise put as private as protected because you intend eventually to use inheritance. So if you go on Canvas and look at look in the in the modules for inheritance and composition, I have some code posted. This is a code that I wrote a couple of semesters ago. But rather than like coding this from scratch, I thought it would be a nice example to tell you of when you would do that sort of mentality, okay? And so I'm just gonna go over this code very briefly, but it's there for anybody to play with, okay? And so this code, I have a couple of different codes. I have animal code, and I have inheritance code. Darren, I like the animal one better. Okay, so where is it? Okay, so so we'll get to this one later when we do composition. So here is this one. Okay, yeah, okay. So in this one, I have a 2D coordinate system. So kind of what I was doing with the 2D and the 3D. And then what I want to show you with this is we have protected and we have private, right? And you will see that I have things with some comments saying like, try commenting this out and so on. And the reason I do that is because I want you to play around with this code and actually run into the errors that we ran into today so that you can see that. So what I really want to just make sure you get is how the code is set up. So we have a constructor, we have an X and a Y, and then ignore the this reference right now. This will be explained later when we talk about memory. And then we have an accessor function, we have a mutator function, we have a random print function, we have a destructor, which doesn't really do much, and then we have a private and we have a protected variable. Okay? Then we have our inherited class, the 3D coordinate system. In this inherited class, we are going to have a new variable, which is z, and we're going to have the accessor and mutator for those. This is the get is the accessor and the set is the mutator. We're going to be overriding our print coordinate system, so we're going to overwrite the function that we had there with a new one. And then we have just a useless destructor, okay? So, it's almost like the same thing that I did on paper, but, feel free to play with it, and I think it's a good example for that. I thought the animal one was inheritance, so I'll actually revisit that later, because that's the one that I thought would be useful. But, if you want to have a good example of something that you want to have inheritance for, I can always pull up or draw some, so let's just do that. Because, I think one of the issues that people might have is they don't know yet. Like, when do I use this? When do I not use this? So, suppose you're coding a video game, okay? And so, if you're coding a video game, you may want to have a shared class amongst all of your classes, and that is going to contain all the things that you really want everybody to have. So that could be like your entity class or entity and type. Okay? In that class, you can have things such as like an identifier, maybe a position, but depends if you want all entities to have a given position. You may not want to, so that's up to you. But let's just put it in. Why not? Position, X, Y, Z. Other things that you could have in there could be some special references, pointers, but we don't want to talk about pointers right now. Maybe a name associated with the entity, and then maybe let's just say you have a string called note, so you can keep tracks of whatever you want there, like some documentation. Okay, so once you make this, you probably are going to make all of these protected variables, and then you have your public functions. You could also have some protected functions. You might even have some private functions that you intend only to work on this subset of code. From there, you can make a bunch of inherited classes, such as like different entity types. So like you might have a player, you might have like an NPC, which is like AI. You could have like just an object, but it's not like an actual NPC object. So just like an actual prop in the room or something. You could also have like a trigger. I don't know if a trigger would be an entity, but you could do that too, and so on. A trigger, like, if a player walks through this, it activates something in your world. And then from there, you could even have inheritance to other levels. Like, there might be different kinds of players. Like, this might be some magical games. So you have like different classes, or it could be like a first-person shooter. So you could have like the medic class. You could have what are thinking like Battlefield, medic, sniper class, I guess, sniper. Support, right? Those are like the big, like the rocket launcher dudes, or like engineers. And then there's just your normal like assault/soldier class, I guess. Yeah, okay. There you go. And so on. Okay? So really, yeah, I actually should have put that all the way down here. There we go. So really, as you're developing this, you already have an intention to do inheritance. So you can think about ahead of time, like what you want to have protected public, and like what kind of things you could add extra here. Like there's so much things, like, you know, you could have HP, you could have I don't know, stamina, like weapon slots. For props, you might have different things, like, you know, some strings that keep references to like the textures that are loaded in. The NPC is probably going to share a lot of things with player in terms of HP and structure. So you could even have a common class for that. You could have a class called like living thing, and then like that would be shared, and then that way you don't have to repeat yourselves, because there's a lot of things that the NPC and players might be able to do, like grab an item from the floor and be able to shoot things. But the AI is going to have special things that the player won't have, and vice versa. So you have to do this sort of design choice before you go out there and code. And that's when you decide whether you want things to be public protected and private, and you can throw in your UMLs and do all these great things, okay? However, you have to be careful when you do this, because you can run into some issues. And I'm going to talk to you about one of those main issues in a little bit. But before, I want to test the struct example. Remember, we said what happens if you inherit a struct? Is it going to inherit as private or not? So I want to test that. So let's go ahead and just do that. So how do we do that easily? No, let's just do it down here. So I'm going to make a struct A. And this struct is going to have an int x. That thing should be public. And now I'm going to make a struct B. And that struct B is going to have a inheritance from A, like that. And then now, what I really just want to do here is have a function foo that just counts A. Sorry, not X. Right? And so in theory, if the inheritance is private, then X will be private and this should not be able to access it. If it's public, then we won't have a problem. So let's find out. Well, we got a bunch of errors, but I don't have any of those errors. I think that's just unrelated. Oh, here. I don't know why I put those parentheses like that. I'll fix a bunch of errors. Okay, so it compiled. That's a sign that maybe this will work. Well, let's actually see. Let's try. I mean, I think it's gonna work, but let's just see. So let's try. Let's make an object of A, and let's make an object of B, and let's try to call B foo. And see what happens. Because let's think about it. X here is public because struct public by default. Foo is public by default. But is this inheritance public or private? By default, inheritances are private. But here, because it's a struct, I want to know if it's going to be a public inheritance or not. So it ran. So it does appear that when it comes to inheritance, when you're inheriting a struct, it's public. Now, can I explicitly make it private? I think I can. I don't see why I wouldn't be able to. But let's see. We're in unknown territory now. Ooh, that's scary. So it's ignoring the fact that I'm saying private here. It's like, yeah, that's no problem. It's all good. That's scary. Okay. What if I put the word private here? Okay, so that it doesn't like. However, even when this is public, adding the word private here does not seem to be doing anything when it comes to a struct. Now, if I change this word to class, see if that doesn't work. Okay, so changing that to class, then it allows me to do the, by default even, it will give me the error, right? So the act of me putting the word struct here and then using inheritance appears to force the inheritance to be public. So I guess that's one way to trip somebody out. Write the word private there, because you would think that the inheritance is private, but the fact that you're writing the word struct forces the inheritance to be public. That's a first amongst all of the, well, not all, but but amongst at least the multiple semesters that I've taught 202, I never thought about doing this. And in my own personal coding, I mostly do Python, but in my own personal C++ coding that I've done, I've never thought about doing that. So I just learned something right now. So that's cool. I mean, I don't know why I'd ever use this, which is probably why I've never ran into this, unless I'm trying to do something intentionally, sneaky. But that's cool. Low-key, I mean, I don't do the test, but if I did, I would do this as an extra credit question to see if people saw the lecture, because, I want to know, yeah. So, yeah, but this is pretty cool. I'm going to have to bring it up with the other instructors, see if they know. I'll be smart, be like, oh, have you tried this? Obviously, everybody knows that the inheritance is going to not be affected by the keyword. So, but yeah, that's cool. Maybe they all know, I just never tried it and been also foolish, but I'll leave it there. I'll leave this like this and be like whoa. So, yeah, that's cool. See, you're learning, you never finish learning a language. Don't ever let anybody tell you they're an expert in language. The more you know is the more you know nothing. So, yeah. Okay, so after that very illuminating moment, now we can come back to talking about this. Okay, so you already seen how inheritance works with public, protected, and private. Play around with the protected stuff. So when you inherit protected, things that are public will become protected, and so if you inherit it again, those are going to stay protected. So play with that, explore, run into errors, fix the errors, because you want to have that exploratory phase now before you are trying to get a program working, and then you see the errors and you're like, what the heck is going on, kind of thing. Okay, so I encourage you to do that. But I'm going to move on to talk about a specific scenario, and that is that in C++, which is something that you can't do in a lot of languages, particularly, for example, Java, you can't do it. But in C++, there is a concept known as multiple inheritance. Now, what is multiple inheritance? Multiple inheritance is when you want to inherit from more than one parent. So it's kind of like humans. Humans don't just inherit traits from one parent, right? To create a human, at least in 2022 that we publicly know of, to create a human, it takes two sets of DNAs, right? That they get spliced together, mixed together, you get about 50-50 of each. Not exactly, but you get 50-50, and then you create a human, right? So that's technically multiple inheritance. Although the way it works in C++ is more like you take both parents, the entire stuff, and then you smash them together, and now they have exact copy of both, or I guess references, not copies. Okay, so that would be like saying, okay, if a kid has, four pairs of or two pairs of eyes, one from the parent and one from the dad and one from the mom, from two parents, from both parents. So it's not like they would have mixed eyes. Like they literally would have four eyes, okay, and four ears, two noses, two mouths, kind of scary. But that's what multiple inheritance is. And it's also why it's not always the ideal and safe, and why some languages prefer to just not even have this feature. So, like anything else, I'm going to show you how it works, and then I don't think I'll get to that today. I'll get to it probably next lecture, but I will show you the risks associated with it and the big issue that we have with it, and sometimes how to approach the issue, but we'll revisit that later. Okay? So first, let me just show you the syntax. Like, how do you do this? So let's take our current class. Might as well copy class A and B. So let's just take class A and B that we did earlier. There we go. Okay, so we have class A that has some variables, and class B that takes those variables and kind of builds upon it. And now let's go ahead and create another class. And this class is just going to be called class X. And class X is going to be public. And it's just going to have a variable. Very simple class. We're just going to call it int. I was going to say X, but it's kind of weird to call X there. So like, let's just do int B like that. Okay. Obviously, when I do this, I'm just giving you a basic example, but this class could have 1 billion variables and another 1 billion functions. Well, hopefully not 1 billion, but a lot. Okay. So your class B is cool and it works great, and you're like, I really like class B because I have all the stuff from class A, but I also wish I had the stuff from class X in class B. Can you do that? Yes, don't let your memes be dreams. All you gotta do is inherit it too. So what do you do here? You just put an X in there. Like that. And so now class B is actually inheriting from both class A and class X. Now a couple of caveats here that I want to point out. You saw me write the word public there. A lot of the times when people do multiple inheritance and they don't know what they're doing, they'll do something like this. They'll do class, some variable name, again, just make up different letters, class N, and then they'll say, I want to inherit publicly from classes T, U, and C, okay? And they just call it a day on that. And they're like, oh, I'm inheriting publicly from T, U, and C. Like, it's all good. No. You have to specify for each of the inheritances whether it's a public, private, or protected. And if you don't, like in this case I'm not, it'll default to private. With whatever weird exception structs will do, which now I'm probably going to everything be set to public. But yeah, ignore structs. Forget about that. Never happened for at least the next 5 minutes, okay? So, yeah, you need to specify it like this, okay? If not, it'll default to private, and then you'll be pulling your hair as to why this code is not compiling and why you're not able to access something when you're doing publicly. So that's my first warning of you, okay? The second thing, as you saw by here, is that I'm not limited to 2 inheritances. Like, you can do you can inherit from like 50 classes and make like a super class that, well, technically it's a subclass, but it's like an uber class that has like tons and tons of content from other classes. Good luck. Good luck with that. Have fun. But I'm not doing that. But yeah, it can get really messy. So multiple inheritance is not limited to 2 classes. You can do as many as you want. Just make sure you specify what it is and understand what is happening. So in this case, class B contains everything from class A and also everything from class X. You can run into some issues with this. The issue number 1 is, what if variable names are shared? So like, what if class X has a variable name called T, and then class A has a variable name T? What happens there? Let's try it out, actually, because I want to show you some stuff with that. So let's actually save this into a new file. So bye-bye, battery example. Thank you for your service in our class. Oh, I still left the comment saying car class. Should have said battery class. These examples are available on Canvas for you to download and play with. Just be aware of that. And check them out. Okay? Okay, so let's do class. I'm going to change my example because it bothers me that the letters are not alphabetical. So I'm going to have an int A, B, and C. So I have class A, class C. Or, sorry, class B, not class C. Int Y. And then maybe like class C, which is the one that you're going to have the multiple inheritance from. So C inherits from A and from B. Okay? And we're going to make it public for now. We already talked about all the issues and stuff about public versus protected when inheriting. So there's no need to repeat that. So I'm just gonna skip that level of, you know, complexity by just making it public to prove the point. Okay, so there we got our classes, right? And right now, I mean, this is all good. There's no real any conflicts that we have to worry about. I can make classes. I can make A's. I can make B's. I can even make C's. And I can access everything from, you know, X and Y. Now, I know I'm not printing it, but the point is that if it compiles, technically I am able to access those. It's just I'm not printing them out, okay? So now comes the issue that let's say that class A had the int t in it, and then class B has the int t in it, okay? Still compiles, but the problem is gonna run into here if I try to do c.t, right? Like this time, let's actually put some numbers in here so that you can see. You're like, huh, which one's it gonna print kind of thing? Well, neither, actually. It's gonna give us an error, right? Because it's gonna be confused. It's gonna be like, huh, which t are you talking about? Request for member t is ambiguous. Okay, let's look at how that looks here. Because like I said, I love seeing the errors here. In function main, error. Request for member t is ambiguous. C out t, so it tells the line. Candidates are int bt and int at. You can see it says, so b, scope resolution operator, is saying T from class B and T from class A. It's like, which one are you talking about? Like, yo, what is this? Like, what the heck, man? Kind of thing. All right. So yeah, that's our first problem with multiple inheritance, that if you have variables that have the shared name and you try to access them, you got to tell it which one you're talking about. How do you solve this issue? Well, you can solve it. It's viable. You have to specify which class you're talking about. So in this case, if you want to get the one from A, you have to say that's the one from A. If you want to get the one from B, then you have to say that's the one from B. Is that syntax going to work? Nope, that syntax is not going to work. What's the syntax for this? Shoot. Okay, let's kind of... maybe that syntax will work? Now I don't even remember myself. Yeah, okay, that syntax will work. Okay. See, that syntax is just so bad that like you would never really want to do this. This is like really if somebody forces upon you this multiple inheritance where the variable names are shared, then you're already there like in a losing scenario. So this is like more like, okay, at least we got it working kind of thing, but like please can we not do this anymore? So yeah. But there you go. See, you got the 5 and the 7. So you are able to access both and modify both. And they are independent variables because they are. Like this t is completely different from this t. So like you changing one of them is not going to change the other one. So as you can see, this is some nasty syntax. So C member access operator, class name, scope resolution operator, and then the name of the variable. That worked. Not ideal. It's even worse because like if you don't do this and you don't ever touch it, like the code runs and it's fine. It's only when you're finally going to go access one of these variables that you actually run into the problem. You know, right now it's not because I don't have it, but you know, you run into the problem like that. So not fun at all. That's one issue that you are going to have with multiple inheritance. But it gets worse than that, actually. So yes, the pro is that yes, if you like don't get me wrong. If it was all bad, then like they would have removed it, right? I mean, other languages don't put it in because they don't want to deal with the bad. But C++ is like, nah, we can handle the bad if there's some good in it too. So, and there is. When you do want to inherit from two classes because you both have what you want and you don't see these issues coming up because things are coded better, or if they do is from like one variable or something, then you just go with the multiple inheritance and you call it a day. That's okay. It's like, you know, it's part of the language. Use it if you need to, and use it to your advantage. Don't just because I say it's not good doesn't mean you shouldn't use it. I'm just saying, be careful with it because most of the smart people in the world think that this is not a good thing to have. So like, you know, there is an argument to be made. So you know, tread carefully, but still use it. It's like if we didn't take risks in life, then we wouldn't get anywhere, right? So yeah, okay. So, however, the one thing that you really should avoid, and like this one, like just really don't want to do it unless, like, again, this is really like, this is like an Avengers level threat. You want to avoid this. But like, here's what's going to happen, okay? Suppose that you have, and for that I have pictures. So I'm gonna get some pictures in here, okay? I wish I had cool pictures. Now that I say Avengers level threat. So let me first of all hide it. You know, I want it for dramatic effect to show it the right way. So, yeah, gotta get that dramatic effect. Okay, so let me switch back now. All right, so here we have a scenario. Actually, A and B will kind of match the A and B that we did, right? So we have A and B, two different classes. Both are amazing. They both implement some really cool stuff. You like them both, but they kind of live their own worlds, right? And so time goes on, and then your boss is like, yo, A is cool, but we need more for A. So now you expand A. So now you get this class kind of like AE or something, okay? So A expanded. So it's still got the blue circle, but now we got this pink X outer circle, which represents additional functions and methods that you have. Well, methods and variables that you have, okay? This is where things start to get interesting though. On this side, you start to expand the A further, or AE, I suppose. So now we have the green outer layer. And on this side, this little triangle, you're like, wow, this class is so cool. Can't we like put these two together? And so you do. You make AEBE. So this is built from A expanded, combined, or with multiple inheritance, with BE. So here you have your first example of multiple inheritance, this one. Okay, this one's just a simple inheritance on two levels. That's okay. That's pretty common in most languages. In fact, it's like the video game example, right? This was like the entity, then you have the player, and then you have like the medical class. So here you have multiple inheritance, but it's clean. You have your triangle stuff that you wanted. You have your expanded A, which is the blue and pink. And then because you're doing the multiple inheritance, you may be enhancing them, right? Maybe you have extra functions to connect them and do things together, whatever you want. So you got some really, really cool stuff. So far, this is a good usage of multiple inheritance, good usage of inheritance. The world is good. Then problems are going to come. You are like, oh, I really love these two classes. Like, especially because of the enhancements that I did for the green stuff and like the brown stuff, which are, you know, this and this. So then you're like, okay, why don't we make like this really cool class that contains both of them? And so this monster is born. This has both, as you can see, the expanded A on the second level, and it has that combined of A expanded and B expanded. And of course you have extra stuff around it. This is a problem. This is what's known as the diamond problem. And you can see the shape of the diamond if I zoom out. So you have this here and you have this here, right? Why is it known as the diamond problem? Because you are inheriting from here and you're inheriting from here, and then you're inheriting back together. So this is like, you know, not to insult anyone or anything, but this is kind of like incest, okay? You basically have one level of kids which carry the original shared, which is this up here. They both carry a copy of that. But then there is the incest, which brings you down to this. So now you have a problem because you have the twice AE expanded here. You have the blue circle twice. The blue pink circle, you have it twice. That's a big problem with the programming. The code will compile when you do this inheritance level. But when you do it like that, all the variables that you have in basically in here, you also have a copy here. So the simple example that I did trying to separate them, so like this stuff here, that only happened because like we had a variable that was named the same, right? Even though technically they're different things, they just happen to be named the same. Well, now imagine that for the entire class. Every single variable and function has this issue. And not just that, but like they actually represent the same thing, which is even worse. Because you might be like, oh, I only really wanted to have one blue and pink circle. Like what I this is like when you saw this and you wanted to do this, let me show you what maybe you were thinking in your head. before you actually did this. Like you in your head you were thinking maybe what I'm going to get from this is going to be like this, like expectation versus what you get kind of thing. You wanted to get all the cool stuff but not get any repeats, because now you have basically 2 instances of a class when you really only wanted 1. Like that. This is what you wanted. That's what you wanted. So what you wanted, what you got. Okay? So needless to say, the diamond problem is the reason why multiple inheritance is not allowed in other languages, because this is just a pain to deal with, and it's just bad programming technique to even end up in this situation. But you have to be careful, because like here it's obvious, like, you know, you see the parent, you see the common ancestor per se, and then you see the diamond shape. But if there's a lot of classes in between this, it might be a little bit harder to actually track that this even happened in the first place, because you're using libraries and stuff, and so it just becomes an issue. And so I think that's all I'll say about the diamond problem. Again, as weird as it sounds, the best way to think about this is like incest. And you can work around this by referring to the variables by their class names. Just be aware that like there's 2 instances of that variable, and you have to keep track of that. Otherwise, you're just going to get confused, and it's going to be a mess. Okay? I have other videos on the diamond problem from other semesters. I think in some semesters I did examples. This time around, I feel like it's not necessary. So I didn't do any fancy examples, but I do have an example where I do like mom, dad, and kid. It's kind of weird, but it's there if you want to see it. So yeah, I just, you know, whenever you talk about inheritance, you kind of have to talk about this, because it's the big warning. Okay? Not to say inheritance is amazing. It's just multiple inheritances where you have to be a little bit careful to not run into that kind of situation with the diamond problem, or just in general issues with variable names being shared. Okay? So that's it. We're actually out of time. So I'm going to call it a day there. Next time we're going to be talking about composition, which is an alternative to inheritance. Well, not alternative, but it's useful in other scenarios where inheritance is not ideal. But you still want some sort of similar functionality. So that'll be the topic of the next video. And then we'll be done with inheritance and composition. And I think then we get to move some really cool stuff with memory and pointers. So that's when things start to get exciting. So thank you all for watching today, and have a great day. Thanks.